Let's continue chapter 34, lesson 5, Ohm's Law. Now, Ohm's Law states that the current in a circuit is directly proportional to the voltage impressed across the circuit. So here, as we remembered before, or as we said before, we talk about the current. And we say, what is the current? It is a charge moving in a certain time in the cord. And the voltage is a potential difference across the circuit. So we know what is the voltage. We know what is the current. The relation between the current and the voltage, we call them law. So the Ohm's law states that the current in a circuit is directly proportional to the voltage impressed across the circuit and inversely proportional to the resistance of the circuit. So if you have a current and the voltage, and you have also R, which also we talk about them, which is the resistance. Ohm's law, they make a relation between the current and the voltage, and they are directly proportional. And they are also inversely proportional with the resistance. So the law that is make a combination, a relation between the current, the voltage, and the resistance is an Ohm's law. Electrical resistance is measured in a unit called ohms, as we said before. Resistance, R, its unit is ohm. Georg Simon Ohm is a German physicist, tested wires in a circuit to see what effect the resistance of the wire had on the current. The relation among voltage, current, and resistance is called Ohm's law. So there's a man whose name is Georg Ohm. He writes a relation between the current, the voltage, and the resistance. As I told you before, the current is directly proportional with the voltage and inversely proportional with the resistance. So we can say that I is V over R. This is Ohm's law. They make a study that if I have 220 volts as an example, and the current here is 2 ampere, and there's another current which is 100 ampere. They want to see if the current is low, shall the resistance will be low or will be high? And if the current is high, how the resistance will be? It will be small or low or high. So they make a test. They see the effect of the resistance if we have a current and voltage. So here, this is the most important rule in electrical engineering, which is Ohm's law. Current is voltage over resistance. There's a relation between the current and the voltage. They are directly proportional. We say that the current is directly proportional with the voltage and inversely proportional with the resistance. I is V over R. This is very important one. Current is voltage over resistance. For a given circuit of constant resistance, current or voltage are proportional. If you have a circuit, you have the same resistance, like I is V over, let's make them a constant, like over 2. And they have another one, and also the resistance is 2. So if the resistance here is constant, so there's a proportional or directly proportional with I and V. What does it mean? That means if I want to increase the current, the voltage will be increased. And if I want to decrease the current, the voltage will be decreased. Why? Because I told you, Ohm's law tells us that if the current and the voltage is directly proportional. And if I imagine now, you have an V over R, but let's make V is constant. If V is constant now, so I and R are inversely proportional. What does it mean? That means if you increase the current, the resistance will be decreased. Or if you increase the resistance, the current will be decreased. So I will repeat. Ohm's law gives us the relation between the current, the voltage, and the resistance. Between the current and the voltage, they are directly proportional. And between the current and the resistance, they are inversely proportional. Twice the current flows through a circuit, twice a current, it means twice the voltage. So greater voltage, it means greater current. As I told you before, I is V over R. So if you twice, let's say, twice a current, it means you will twice the voltage. If you increase the current, you will increase the voltage. But here also, if you twice the current, and since they are inversely proportional, so you will have the resistance. Or, and easier to understand, if you twice the resistance, that means you will have the current. I will repeat. Why? Because the current and the resistance are inversely proportional. But the current and the voltage, they are directly proportional. So here, if you know that in Ohm's law, I is V over R. And I told you now, if you multiply or if you triple the current, what will happen with the voltage?
Triple.
It will be tripled also. But if you triple the resistance, what will happen with the current? Look here, it is 1 over 3. It's imagine like 1 over 3. So it will be third the value. So if you increase the resistance, the current will be decreased. Is it clear?
Yes, miss.
Yes, teacher.
Grade 11.
Yes, teacher. Yes, teacher.
Yes, teacher.
Okay. So I will repeat. Ohm's law, I V over R. This is an Ohm's law. let's talk about the units of measurement. All of us know that the unit of current is ampere, the unit of voltage is volt, and the unit of resistance is ohm. So you can write it as 1 ampere equal 1 volt over ohm. In units, I, V over R, or ampere is volt over ohm. That's mean a potential difference of 1 volt across a circuit that has a resistance of 1 ohm. Here you have a voltage and 1 volt in a resistance of 1 ohm. They will produce a current of 1 ampere. Or if the voltage of 12 volt is impressed across a same circuit, I mean 1 ohm, so that means the current will be 12 ampere. This is using the units of measurement. 1 ampere is 1 volt over 1 ohm. 12 ampere, it's 12 volt over 1 ohm. Now, I told you that Ohm, or George Ohm, they make a relation between the current, the voltage, and the resistance. They make that, or they say that if we have a potential of, if you have the potential difference is constant. Let's try, or let's see, what is the relation between the current and the resistance? After they make his study, they find that, he found that they are inversely proportional. What does it mean? Look at the first picture here. In this picture here, we have lamp cord. This is a lamp cord. For this lamp cord, we have a high magnitude or high current that's passing through the circuit. So since we have high current, so we have low resistance. They have low resistance. Low resistance, it's mean like it is very, can say like it's a very thin man. He cannot resist anybody to come. So there's a very big amount of current that allow them to pass through the cord. So it's low resistance. It means it's a very small, it's a very weak woman, you can say. This weak woman, it can allow a very big magnitude or a high current to pass through the cord. But if you have a high resistance here, in the second picture, or in the lamp, in the second picture here, we have high resistance, which is 100 ohm. In the first one here, we have 1 ohm. Here we have 100 ohm. Since we have a high resistance, since we have a 100 ohm, so we have low current. In the third one here, we have an electric toaster. The electric toaster have a 15 to 20 ohms. This is just an example how the lamp, small lamp, is 100 ohm. And the cord is only 1 ohm. But if you look at the electric toaster, it has 20 ohm. So how the resistance of the lamp will be high. So the low resistance permits a large current, which produced considerable heat. That's why sometimes you cannot touch the lamp. Why? We have a high the low resistance permits a large current which produced a heat. Okay, that's mean here you give you a heat for the toaster. That's why they make here a low resistance. This low resistance, it make the current high, so it makes them, or it makes you give heat. So here, low resistance, high current. High resistance, low current. Like, did you remember when we said in the first semester, when we say that if we have a, this is a thin, and this is a large one. Talk about the wires. For the, imagine now here we have a thin wire. Thin wire, that's mean we have a low resistance. Since we have a low resistance, what about, imagine now here we have a very thin wire. What about the current that's passing through this wire here? It will be great. It will be big one or small. It will be high or low. The magnitude or the amount of voltage that is across or that is passing through the wire.
High.
It will be high. If it is low resistance, it will be high. But if you have here and a high resistance, if we have a high resistance, you can make that we have an Superman. It have muscles. He have a high resistance. Can he permit a current to pass, or they give me a few magnitude? So the low resistance here in the toaster, since we have only 20 ohm, so this, since we have a low resistance, it allows a large current. This large current make a heat to make this bread, or to toast this bread, or to heat this bread, you can say. But if they make it or they manufacture it with a large ohm, imagine now this toaster with a large ohm, with 100 ohm, how the current will be? It will be very small. So since it will be very small, it will not give you enough heat. Now, here also in a circuit, the current that is passing through a circuit, they will not passing randomly or in any way they want to choose. No, they are regulated. They have something we call them a resistor. So in any circuit here, imagine that in this picture here, we have this circuit element. The current want to pass in the circuit. How? By using the resistor. So what is the resistor? The resistor is a circuit element that regulates the pass, or you can say it's like a street, you can say. It's like a street that regulates the movement, the passing of the current. Now, the strips on this resistor, look at this cylinders here. Do you see the wipes and the cylinders? These wipes is these cylinders with the wipes is the stripe, or can say it's resistors that regulate the movement of the current. Now, if they want to measure or to indicate the resistance for each current, they use these stripes, the color stripes. The white, it makes a measure. Oh, it means something in electrical. But look at the black one. For the black one, there's no resistance here. For this one, there's no resistance. Only the stripes or only the cylinder with the color stripes. Is it clear?
Yes, teacher.
Yes, teacher.
Now, how much current is drawn by a lamp that has a resistance of 100 ohm? So here you have a resistance of 100 ohm with a voltage of 50 volt. I want to find the current. All of us know before that a current is a voltage over the resistance. Voltage is 50. The current is 100. So the resistance is 100 ohm. So I have 0.5 ampere. This is how to use Ohm's law in mathematics. Now, so if you know two of the three quantities, you can solve the third. I told you that the three quantities that make that's George Ohms make a relation between them, which are voltage, current, and resistance. Voltage with V, current with I, resistance with R. It's abbreviations. The unit of voltage is volt, the unit of current is ampere, the unit of resistance is ohm. I can write volt as V, ampere as A, ohms by this sign here. What are these three? Oh, you can make a derivation, we can find a differentiation of this Ohm's law. We said before, I is V over R. If you multiply I with R, what did you get? You get V. So this is a second one. And if you change I with V, I with R, sorry, like V over I equal as R also. If you change them, you will get the third one. So if you know the current and the resistance, you can find the voltage. If you know the resistance and the voltage, you can find the current. And if you know the current and the voltage, you can find the resistance. Let's have mathematical example here. If a current through a 200 ohm resistor is 2.5 ampere. So here, what is the given information I have? I have a 20 ampere and 20 ohm and 2.5 ampere. I want to find the voltage. I have to ask myself, which of these formulas I can use? I can use the first one. By the way, all of them are the same. So if you know this one only, sorry, if you know this one only, you can use them. So here, because I told you these three formulas are a derivation of the first one. So I can say V is I times R. So since V is I times R, I have V, I have I, sorry, and I have R. I is 2.5 ohm. 20 ampere, 20 ohm is a resistance. So 2.5 times 20 will be 50 volt. So what is the voltage across the resistor? It will be 50 volt. Another example. Here they give me the current, which is 30 ohm. If the current is 2 ampere and the resistance is 30 ohm, what is the voltage will be? I have R and I have I. So which formula can I use?
The first one.
The first one. I need to find the voltage. So V is I times R. I is 2, R is 30, so the voltage will be 60 volts. The last one here. If the voltage across a resistor is 30 volts, so here I have a voltage and I have the current and I need to find R. I have V and I need to find R. Without memorizing them, so here the voltage is 30 volts and the current is 6 ampere. I need to find the resistance. I remembered that I is V over R. I need R. So I just replace I with R. So I will say V over I is R. Then V is 30 over the current is 6. So I have 5 ohm, which will be this choice. Is it clear?
Yes.
Yes, teacher.
So I will summarize the lesson. Ohm's law. They make a relation between the current, the voltage, and the resistance, which is I equals V over R. We have directly proportional I and V, and inversely proportional and I and R. We have 3 formulas for it. I is V over R, or R is V over I, or IR equals V. Then high current, low resistance. High current, high voltage. And what also? And here that if the current want to pass through an electrical device, they cannot pass in any way. They must use a street. They are like a cars. They have to use a street. These streets are regulated by, or these circuits are regulated by a street, which we called it a resistor. So a resistor is a circuit element that are make a regulation to make the current passing through the electrical device. As I told you, these are the strips. These are the resistance. Now, the strips on this resistance, the coloring one, white, red, green, black, yellow, and so on, they are color coded to indicate the resistance in ohm. In electrical engineering, they know that black is 5 ohm as an example. White is 1 ohm. Red is 3 ohm, and so on. So these colors on the stripes are color coded. They know that red is 5 ohm as an example. White is 3 ohm. They indicate the resistance in the ohm. Do you have any question?
No, teacher.
Thank you.